Hello again, this is Ron, FT03, and this is tutorial 3 for the Foundation Theory course, and we're going to be discussing circuit symbols. In radio and electronics, we could draw things the way they physically look. And what I've done here on this slide is draw a battery. I'm just going to get rid of something on the screen. I've drawn a battery, a switch, and a light bulb or a lamp. And I've made a circuit by making a connection from the negative terminal of the battery to the switch, and then from the switch to the light bulb. The light bulb has two connections, and then I've taken a positive lead back to the positive end of the battery. And when we operate this switch, it's an on-off switch, the lamp will operate or go out depending on which way it's thrown at the moment. If we were to draw electronic diagrams using pictures and photographs like that, it would take a long time, it would be hard to read, and it would be very, very complicated. So for that reason, we don't draw pictorial diagrams like this. We draw schematic diagrams. Just give me a moment and I'll show you the schematic diagram of what we have on the screen at the moment. And then we're going to go through and discuss the circuit symbols that you need to know for the foundation theory. This slide shows the schematic diagram of the pictorial diagram on the left, and you see how much neater and tidier it is to draw using symbols and schematic symbols instead of real pictures. This is a symbol for a battery. You would not expect the word battery to appear there, or the word switch to appear here, or the word lamp. You would only just see this circuit without any labelling. We might have resistors with their resistance written on them and some other components. The battery voltage could be written here. So that's the equivalent circuit to the pictorial diagram on the left. When we close the switch, the circuit is made. The small terminal on the battery is negative. The symbol here, that is negative. This is positive. So electrons will flow through the switch, through the lamp, lighting up the lamp, and then back to the positive terminal of the battery. The only purpose so far is to demonstrate to you how important it is, or the need to use schematic symbols on the right rather than pictorial diagrams on the left. Pictorial diagrams are fine for very simple circuits like the one on the left, but as circuits become more complicated, we rely more and more heavily on circuit symbols, and we're going to go through now all of the circuit symbols that you need to know for your foundation assessment. There are altogether about 10 circuit symbols that you need to be able to identify what they are. In your assessment, in your practical assessment, I recall that you only need to get 5 of the symbols correct, 2 of which must be antenna and earth. So we'll get to that shortly. So out of all of these, well, if it was me, I'd know them all. Okay, the first 2 symbols we need to discuss is the electric cell, the single cell. A single cell battery, like a AAA cell, is not a battery, it is a cell. It is a single cell. There is only one set of electrolyte and one set of plates in a single cell. And that is a symbol for a single cell, with or without the positive and negative symbols. The smaller terminal on the symbol is the negative symbol. The longer terminal is the positive symbol. A terminal, I should say. And a battery is a group of cells. And so the symbol for a battery is this one. And you can see here in the picture a 9-volt transistor battery. If we take it out and break it open, we can see there are 6. You can't see the other 6, they're around the other side, but there are 6 individual 1.5 volt cells there, and 6 times 1.5 is giving us 9 volts. So that's a symbol for a battery. This is the symbol for a cell. By the way, the word battery is not an English word. It's not a technical word. It's an English word. A battery means a group of things or a collection of things. A battery of hens, a battery of cannon, a battery of cells. And we just shorten that up and just say battery. Let's move on. The next three schematic symbols, we've only got to do about 9 or 10, so don't fret, it's not too hard, is a fuse, and here we have a picture of a typical fuse used in an amateur radio transceiver or in an appliance around your home. A fuse is a protection device for excessive current. When you put a fuse in a circuit, the current must flow through the fuse wire. And if the current becomes too high, the fuse wire gets hot and melts and opens the circuit. One of the effects of electric current flowing through a conductor is heat. And so a fuse is a melting piece of wire that will open the circuit and stop the current if there was some fault or something went wrong. So a fuse is for protection. A lamp, and in this case, it's an old incandescent lamp, the old-fashioned type lamp, but that could just as easily be a small indicator lamp on the front of a radio. Doesn't have to be a light. It could be an on-off indicator, and it could be coloured red or green or whatever. Symbol for a lamp. Resistor, fairly straightforward symbol. Sometimes a resistor is drawn as a rectangle, not the zigzag lines, it's just a rectangle. That's also a symbol for a resistor. This is the one you're most likely to come across, and this is what a resistor looks like. The coloured bands tell us what resistance it is in ohms, but we don't have to do that. The physical size of a resistor doesn't tell you anything about its resistance. You could have a 50 ohm resistor that weighed a kilogram, and you could have a 50 ohm resistor that weighed a few grams. They would be physically very different in size. The reason for the different sizes in resistors is that large resistors can handle a lot more power than small resistors. When current flows through a resistance, heat is generated. If the resistor is small, it will act like a fuse and burn out. So large value resistors are used where we have a lot of heat dissipation. Large value resistors can withstand a lot of heat. But again, fuse, lamp, and resistor. Bit hard for you to know if you're remembering them during the tutorial. Don't forget you can do the drill software to test your knowledge of whether you've remembered these symbols or not. Do the drill software for this tutorial. See you back in a moment with some more. Rightio, now we have switch. That was the switch we saw in the schematic diagram that I showed you earlier, turning a lamp on and off. We use an on-off switch. When the switch is closed, these two contacts close. When the switch is open, these two contacts open. So that's a simple on-off switch. Need to remember the circuit symbol for that. Antenna, there is only one symbol for all antennas. Excuse me, in this photo we've got a three-element Yagi antenna. We've got a vertical antenna here, a Yagi antenna there. That looks like a TV antenna to me. All of the symbol for all of those antennas is this antenna symbol. And ground means a literal connection to an earth stake in the ground or a water pipe that is buried in the ground or something like that. So on the left hand side I've shown you what a ground would look like. This could be the mast of an amateur radio station, and the amateur has driven in a copper stake and connected an earth wire to it for a number of reasons, safety reasons and better radiation reasons from his antenna. So that's switch, antenna and ground. By the way, you must know antenna and ground. These are the two compulsory symbols you need to know. But if I was you, I would know all of them. There's only a couple more to go. And the very last two symbols you need to commit to memory is a microphone. Microphone converts sound waves into electrical energy, and a speaker. And a speaker converts electrical energy into sound. Strangely enough, and this is not part of your assessment, just as a matter of interest, most, not all, but most microphones and speakers are reversible. So you can actually get a speaker to work as a microphone, and you can actually get a microphone to work as a speaker. Won't sound very nice, sound pretty distorted, but you will be understood, and it's something worth remembering. If you're stuck in the middle of nowhere without a microphone, you could pull a speaker out of something and hook it up and get away with an emergency call. That's it for circuit symbols. Thanks for your attention. Not too hard. Do the drills on it. Make sure the drills will tell you whether you're understanding these tutorials or not. I'll see you back in the next tutorial. Thanks for your attention. Cheers for now. This is Ron, VK2DQ.